Right, now in this recording, I'll be providing a solution for question 9 for this November 2015 question paper. Sikhuluma nge-probability in this question. I have the fundamental laws, 9.1, 9.2, I have a contingency table. In the description below, you'll find recordings for other questions for this paper. Okay, 9.1. Given the probability of A, the probability of B, the probability of A or B, where A and B are two different events. Are the events A and B mutually exclusive? Justify your answer with appropriate calculations or a diagram. So a diagram, it could be a Venn diagram. Calculations, we could use some formulas now, right? So I'm going to stick to our calculations. 9.1, what is a mutually exclusive event? A mutually exclusive event, the event without the intersection, meaning the probability of A and B, the intersection must be equal to 0. So lama events are gonna commonality, they do not have an intersection or a union, right? So singakhombisa kanjani ukuthi lama events lawa are mutually exclusive or not mutually exclusive? Abathi are mutually exclusive, abasho njalo, right? Are they mutually exclusive? In order for an event to be mutually exclusive, this must be equal to 0. So the fundamental laws of a probability. There's two formulas, but for now, so inside this formula, probability of A or B, which is given, the probability of A given, the probability of B is given, minus the probability of A and B. So in this calculation, in this calculator the probability of A and B. Now let us substitute here. The probability of A or B is 0.8. The probability of A is 0.6. The probability of B is 0.3 minus the probability of A and B, which is unknown. Now let us make the probability of A and B the subject of the formula. So I'm going to transpose this to the right hand side, to the left hand side, equal to 0.6 plus 0.3 minus this 0.8 ngiletha ngapha 0.8. 0.6 plus 0.3 is 0.9, minus 0.8, this is equal to 0.1. So the probability of A and B, according to this calculation, is not equal to 0. So it means this event is not a mutually exclusive event. So it's not mutually exclusive. This is not mutually exclusive. Why? Because the requirement for a mutually exclusive event is that the probability of A and B must be 0, but in our case it's 0.1, so this is not mutually exclusive. 9.2. The table below shows data on the monthly income of employed people in two residential areas, area 1, area 2, and then sibanama totals on this third column, and then the last row we also have ama totals as well. Representative samples were used in the collection of the data. 9.2.1, what is the probability that the person chosen randomly from the entire sample will be from area 1? So let's do this. So for this question, 9.2.1a, the probability that the person chosen randomly from the entire sample. So out of 2,646 people in area 1 and 2, baungaki from area 1. How many are they from area 1? So therefore the probability of area 1, let's say this is area 1, is equal to So sizothi the probability of area 1 is equal to this total. Now abantu baku area 1 out of the total of 2646. So it's area 1, the total for area 1 divided by the total number of people both in area 1 and area 2. So it's 1832 divided by 2646. Maybe we can do a further calculation or divide the two. 1832, so that we get a simplified answer equal to 916 1323 B. But from area 2 and n less than 3200. So abubani abahlala ku area number 2, or bangayika abantu abahlala ku area number 2 and n less than 3200. Nabala area 2, this is area 2, bangayika ba n less than 3200 by 462. Laba banye laba they n more than this amount. So 7 are this 460 compared to the entire sample, so meaning so divide that 2464. So is the probability of area 2 less than 3200 is equal to 460 divided by the total 2646 equal to, let us divide, it's 460 divided by 2646 equal to 230. Our answer is 230. 1323 230 1323. C. A person from area 2 who earns more than or equal to 3200. So area 2. So again silawu area 2 foot. Area 2 who earn more than or equal to 3200. So lena out of the picture because of less the class they earn less than 3200. So in this one, it's where or anyone will end up between 3200 and 25,600, and then lana it's more than 25,600. So these two, lena, this one and this one, yes, so 7 in our calculation, or it's the number of people in question. Ngoba laba between this range, which I satisfy this condition, which is more than 30,000 or equal to the 25,000, the x greater than or equal to 25,000 rand is more than 3,200. So add out 340 and then 14 compared, also chosen randomly from the entire sample. So our total is this 2,646 again. So the probability of area 2 greater or equal to 3,200 is equal to 340 plus 14 divided by 2646 equal to, so tige manje 340 plus 14 divided by 2646 equal to 59441. 59441. So this is our final answer for C. 9.2.2.2. 9.2.2. Prove that earning an income of less than 3,200 rand per month is not independent of the area in which a person resides. So lana bakhuluma ngama independent events, yeah, lana sikhuluma ngama independent events, dependent events. So Right, the question ET, let me rephrase the question or the statement. We need to show that an earning of 3,000 or an income of less than 3,200 Rand per month is actually dependent on the area in which a person resides. Is not, I think I underline, is not independent, is not independent, is not independent. It is dependent of the area in which a person resides. That's another way you beg the problem, right? But since not independent, so I need to show Guti this 3,200 Rand is not independent of the area in which a person resides. So it's your calculator, or we are going to use this formula, A and B equal to the probability of A times the probability of B. If the area and the earning are independent, this must be equal. If they are not independent, this will not be equal to this. So into soyenza-ke manje sizothola i-value ka probability of A and B, the probability of A and the probability of B. Then so calculator the right hand side is we has calculated the left hand side and compare the outcomes. 9.2.2, let's go. So the probability, okay, the first thing is soyenza, since it's two events, let's let A be the let's let A be the area of residence. The area of residence. Okay, wait up. I'm not given a space enough, so let's do this. Okay, now let A be the area of residence. Residence. Okay. Residence. Hey, it's Tila. Okay, let A be the area of residence, and then let B be the income. Let B be the income of the residents in that area. So we can either use area 1 or area 2, but for this one let's use area 1, right? So the probability of A is equal to, since I'm using area 1, let A be the area 1 of residence. So the probability of A is going to be equal to 960. Yes, it's about 960. 960. Wait. 900. Okay, wait. Okay, so Lana, it's 960 divided by 2646. So include another spec. I know we are discussing Uluganji, or we are focusing on area 1, but out of the total sample there are other people in area 2 who are earning less than 3,200. So siyaba include another for event A. Let A be the area 1 of residence, or area 1 of residence, and then probability 2, probability B will represent in the income, right? Let B be the income. So tata the total income. The total income in area 1, which is 81832 divided by 2646, right? So let B be the income. There's not only one income with area 1, there are other incomes. Now komeleswa include in our calculation, since we are dividing or we are comparing with the entire sample. So that's why let's add everything. Area 1, the total incomes. Therefore, this is the critical part again. A and B. The probability of A and B is equal to where A no B bamitha khona. So since this is A, no man, this is B, and then this is A. So where these two, where the row and the column meet, senzani, we take that value. That's our A and B. That's our intersection. Ubani 500 divided by the total sample 2646, right? Probability A will represent in the area of residence. So in area 1 and 2 we have a total of 960 individuals or residences are less than 3,200. So let's include everything because we are comparing with the entire sample, right? So compare with the entire sample. I will compare one value and leave out the other values. A fair comparison, right? So therefore, the probability of A and B is equal to this. Let's calculate the product A and B. The probability of A times the probability of B is equal to 960 divided by 2646 times 18332 divided by 2646 equal to so it's 960 divided by 960 divided by 2646 times 1832 divided by 2646. What the hell? Okay, let's break here. Voila. 183226. Yeah. Answer. The answer is 0.25. 0.25. Okay, now let's round it off to 2 decimal places. This one is a 10 given. This one 500 divided by 2646 equal to 0.19. So therefore we can see that A and B is not equal to the probability of A times the probability of B. So therefore it is not, income is not independent of the area or in which a person resides, right? So it means that income, it is in fact dependent of the area in which a person resides. So imagine a case like someone uhlala eKasi kanje, so yabona, and then compare ama residents ahlala eKasi nama residents ahlala kuma suburbs, mhlambe let's say Sandton or something, yabona. So there's going to be an income difference vele lapho, yabona. So it means that in area 1 eKasi, ngiyabekise area 1 eKasi uzothola abantu abaningi aba less than 3,200. Then now you're Sandton uzothola abantu aba more aba an amount which is larger than 25,600. So it is dependent on like income, it is dependent on on which a person resides. 9.2.3, which is more likely, a person from area 1 earning less than 3,200 or a person from area 2 earning less than 3,200. Show calculations to provide your answer. So let's do this. All right, again. Now lana we are comparing two areas. So compare area 1 with area 2. So we don't consider the entire. So probability A2. I guess it dividing a total, but so it divider. Since let's say I'm doing calculation for area 1, this is the total. Area 2, this is the total. So the probability for area 1 of people earning less than 3,200. We need to find our probabilities for area 1 of people earning less than 3,200, and then for area 2 for people earning less than 3,200. So for area 1, bangay abantu aba earner less than 3,200, it's 500. By 500 ku area 1. What is the total number of people in area 1? It's 1832 equal to probability of area 2 less than 3,200 is equal to 460 in area 2 divided by the total, which is 814. Now let us calculate again. Starting at this one, 460 divided by 814 equal to let's take it to 3 decimal places, 0.565 in 3 decimal places. The other one, 500 divided by 1832, this is equal to 0.2773 in 3 decimal places. So therefore, which one has the highest probability? Or let me say the area with the highest probability, they have a higher chance or higher probability of earning 3,200. So therefore area 2 is our answer or our conclusion. Area 2 is more likely to earn less than 3,200. So abantu abahlala ku area 2, they are more likely to earn the 3,200, which is the kasi part of iluganj of society, right? So this is the last question of question 9. Thanks for watching. In the description below ungakhohlwa, there are videos amanye ungawabukela if you're interested. Check them out. Yeah, so thanks for watching. Nangabe enjoyile, leave a like, ungakhohlwa comment, nangabe une question, share nabangani bakho, subscribe as well. I'd appreciate that, guys. So thanks for watching once again. Asibonani on the next one.